The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Welcome back, my dear children. So, previous two classes we were discussing about two important aspects of life. They are mixing and separating, right? Mixing is very important process in our life. Whatever we consume or whatever we do, it's a combination of mixing of components. For example, you are consuming idli, dosha, rice. All these are mixtures of different components, right? Idli, it is a combination of rice, urad dal, water, etc. Likewise, separation is another important technique which is very essential in our daily life. For example, if you are consuming tea, how will you prepare tea? You prepare tea by boiling sugar, milk and some tea granules, isn't it? So, can you consume, after boiling, can you consume it directly? No. So, you have to filter it. So, separation is very much essential there. Likewise, mixing and separating are two important techniques which are very essential in our day-to-day life. Okay? So, this chapter we started with molecule, right? Molecule is the smallest part of any substance which retains all the properties of the original substance, isn't it? We saw the example of sugar candy. When you powder the sugar candy, the smallest part of that sugar candy will retain all the physical properties or chemical properties of the original substance. So, that smallest particle which is invisible to our eye is a molecule of sugar candy. Okay? After that, we saw that molecule forms pure substance as well as mixtures. Mixtures can also be called as solutions. If it is in the liquid form, we call it as solutions. If it is in the solid form, we call it as mixtures. Okay? So, molecule forms pure substance and mixtures. Right? What is a pure substance? If the substance contains only one type of molecule, then it is a pure substance. For example, water, salt, sugar, all these contains only one molecule. Water contains only water molecule. Sugar contains only sugar molecule. So, after that molecule can form mixtures also. If there are more than one type of molecule in a particular substance or solution, we call it as mixture or solution. Okay, for example, sugar solution. So, in sugar solution, what are the two types of molecules present there? Sugar molecule and water molecule. So, two types of molecules are present there. So, it is a mixture. Okay. So, if it is in the liquid form, we call it as solutions. So, mixtures or solutions, they can be of two types. They may be homogeneous or heterogeneous. Okay. What are homogeneous solutions? If the solute is evenly distributed in a solvent, then we call it as a homogeneous solution. For example, sugar solution. When you add a spoon of sugar to water, it dissolves completely in water, isn't it? Evenly it is distributed in water molecule, between water molecules. So, it is a homogeneous solution. How about heterogeneous solution? The solute is not evenly distributed in the solvent. For example, when you add chalk powder to water, to a glass of water, what happens? The solute, that is the chalk powder, doesn't evenly distribute it between the water molecules, right? So, chalk powder mixed with water is a heterogeneous solution. Okay. Other examples we saw kanni vellam, karingali vellam, sambaram. So all these are heterogeneous mixtures, right? In the previous class we were discussing about the separation techniques, right? Yes, you get mixtures and solution when different components mix together. Okay, is it possible to separate these components? For example, chalk powder vellam kudi kalarthi, you get a heterogeneous solution. Ini ipo chalk powder vellam vere aakam pattuvo. Is it possible to separate the components? So we were discussing about the separation technique. What was the first separation technique? Filtration. Yes, filtration is a very important process which we do every day for getting pure water, right? We do at home. So how do you filter water? First thing is you have to sediment the water. If the water is muddy, you have to keep it for sedimentation. What is sedimentation? Leaving it undisturbed. Okay, let it rest for 1 or 2 days. So what happens? The insoluble components. What do you mean by insoluble components? വെള്ളത്തിൽ അലിയാത്ത heavy particles, they will settle down in the bottom of the vessel. ഏത് പാത്രത്തിലാണോ വെള്ളം പിടിച്ചു വെച്ചത് ആ പാത്രത്തിൻ്റെ അടിവശത്ത് you can see mud particles settling down. So that is insoluble components, വെള്ളത്തിൽ അലിയാത്ത components. Okay. After that we do decantation. What do you mean by decantation? ആ മോൾ ഭാഗത്തെ തെളിവെള്ളം ഇങ്ങനെ ഊറ്റിയെടുക്കുന്നതാണ് decantation. After that it undergoes filtration. അതിനുശേഷം ബോയിലിങ്ങോ ഫിൽറ്ററിങ്ങോ ചെയ്യുമ്പോൾ you will get pure water. How will you filter? Using a filter paper. We saw all this in our previous class. We saw one more important technique, that is sieving, which we do in our day-to-day life, right? So where do you do sieving here? When your mother makes puttu, nool puttu, parota or pattiri, she sieves the flour, right? So there the heavy particles are separated from fine particles when you do sieving. So here what is the property used? Yes, the difference in the size of the particles is used in filtration. പൊതുവേ പാർട്ടിക്കിൾസിൻ്റെ സൈസിൽ വ്യത്യാസം വരുമ്പോൾ നമ്മൾ യൂസ് ചെയ്യുന്ന ടെക്നിക്കാണ് ഫിൽട്രേഷൻ ടെക്നിക്ക്. സീവിങ് ചെയ്യുമ്പോൾ heavy particles, that is bigger particles, will settle down in the sieve and finer particles will come through the sieve, right? Fine particles എടുത്തിട്ട് നമുക്ക് പുട്ടും പൊറോട്ടയും കാര്യങ്ങളൊക്കെ ചെയ്യാം. പക്ഷേ ആ ഹെവി പാർട്ടിക്കിൾസിനെ what do? We usually discard it, right? We don't use it. How about in construction sites? അതും നമ്മൾ എക്സാമ്പിളായി കണ്ടു. കൺസ്ട്രക്ഷൻ സൈറ്റിൽ ഈ എംസാൻഡ് അല്ലെങ്കിൽ ഈ പാറപ്പൊടി യൂഷ്വലി സീവ് ഇറ്റ്, റൈറ്റ്? കുറച്ച് ആൾക്കാർ അതിനായിട്ട് സീവ് ചെയ്തുകൊണ്ടിരിക്കും, ചലിച്ചുകൊണ്ടിരിക്കും അല്ലേ? എന്തിനാണത്? നല്ല ഫൈനായി കിട്ടുന്ന പാറപ്പൊടീനെ തേപ്പിന് വേണ്ടി, തേപ്പ് പറഞ്ഞാൽ നമ്മൾ കെട്ടിയതിന് ശേഷം തേക്കില്ലേ, പ്ലാസ്റ്ററിങ്, വി കോൾ ഇറ്റ് ആസ് പ്ലാസ്റ്ററിങ്, അതിന് ആ പർപ്പസിന് വേണ്ടി യൂസ് ചെയ്യും. ഈ ഹെവി പാർട്ടിക്കിൾസിനെ എന്തിനാണ് യൂസ് ചെയ്യുക? ദേ യൂസ് ഇറ്റ് ഫോർ കൺസ്ട്രക്ഷൻ. ബ്രിക്സ് ഒക്കെ വെച്ചിട്ട് ഇടയിൽ പ്ലാസ്റ്ററിങ് ഇത് കൊടുക്കില്ലേ, ബൈൻഡിങ് കൊടുക്കില്ലേ, അതിന് വേണ്ടി നമ്മൾ യൂസ് ചെയ്യും. സോ ദ ഹെവിയർ പാർട്ടിക്കിൾസ് ആർ യൂസ്ഡ് ഫോർ construction and the finer particles are used for plastering. So all these process, that is filtration, under filtration we discussed about sedimentation, decantation and sieving. All these separation techniques are done if there is a difference in the size of the particles. Okay, for example ചായ അരിക്കുമ്പോൾ എന്താ സംഭവിക്കുന്നത്? heavier particles will stand in the sieve and the fine liquid without the tea granules will come through the sieve, right? So avada particles തമ്മിൽ സൈസിൻ്റെ വ്യത്യാസം വരുന്നതുകൊണ്ടാണ്. Moreover, they are insoluble components. അപ്പോൾ ഒരു മിക്സ്ചറിലോ ഒരു സൊല്യൂഷനിലോ ഇൻസോളിബിൾ കോമ്പണൻസ് ഉണ്ടെങ്കിൽ, അതായത് അലിഞ്ഞു പോകാത്ത കോമ്പണൻസ് ഉണ്ടെങ്കിൽ, the technique used is filtration. Understood, children? So question ഇങ്ങനെ ചോദിക്കാം, how will you separate the insoluble components from its mixture or solution? But what is the technique used there? The technique is filtration. It may be sedimentation, decantation or sieving. So, according to situation we can change the techniques. Okay. So, I hope filtration is clear for you. And what is the property used here? Please remember that. What is the property used? Difference in size of the particles. If there is a difference in size of the particles, filtration technique is used. Shall we move to the second technique? The second technique is evaporation. Okay, now children, take a glass of water and add 1 spoon of salt to it. Mix it well. Now what happens? Yes, the solute, that is the salt, completely dissolves in the water. Now is it possible to separate salt from water? Is it possible to separate the components? We call it as components. Yes, it is possible. This is what is being observed in seashore. They will manufacture salt from sea water. Have you seen that, children? Yes. എങ്ങനെയാണ് ഉപ്പ് എടുക്കുന്നത്? കടൽ വെള്ളത്തിൽ ചെറിയ ചെറിയ പിറ്റ്സ് ഉണ്ടാക്കും. കടൽ തീരത്ത് കുറച്ച് അലകൾ തട്ടാത്ത ഭാഗത്ത് വിൽ മേക്ക് സ്മോൾ പിറ്റ്സ്. ഓക്കെ, കുറച്ച് ആഴത്തിൽ 2 feet or 3 feet ആഴത്തിലുള്ള പിറ്റ്സ് ഉണ്ടാക്കും, കുഴി ഉണ്ടാക്കിയിട്ട് അതിലേക്ക് നമ്മൾ ഈ കടൽ വെള്ളം അതിലേക്ക് ഒഴിച്ചു വയ്ക്കും. എന്നിട്ട് ആഫ്റ്റർ 2 or 3 days we can see only salt in those pits. And what happens to the water? It completely evaporates. Who helps in evaporation here? The sun, the ultimate source of energy. Okay, those using the sun rays, the water completely evaporates and the pits are filled with salt, pure crystal salts. Okay, so this salt is being processed many times and iodine is being given and we use it as powdered salt. Okay, evaporation is the process used as a separation technique when the components are dissolved. Okay, so dissolved components can be separated using the technique evaporation. Okay, children. So for insoluble components, alinju pogatha components anengil you do filtration. If it is soluble components or it is completely dissolving, then we use a technique called evaporation. So anything can be done like this. Any solute which dissolves in water can be separated using evaporation technique. If you add sugar to a glass of water, the sugar completely dissolves in water. Is it possible to separate sugar and water? Yes. When you do the evaporation technique, when you boil the water, there you have to give boiling. In laboratory we can do that. When you do boiling, what happens? Heat is being given, water molecule starts evaporating and sugar is left out. Okay, children. So 2 techniques we have discussed. Shall we move to the next technique? Have you seen fabrication shops? What do they do in fabrication shops? They make metal doors, windows, etc. Steel rails, all these are done there. What do they use there? They use either steel, stainless steel, sometimes aluminum or iron. So when they cut these, the scrap materials go out. So what happens? Aluminum powder and iron powder get mixed. Now is it possible to separate these 2 powders? Here the components are both solids, they are insoluble, but is filtration possible there? Can you filter aluminum powder and iron powder? No, it is not possible. Here we use another property, that is magnetic property. Yes, to a mixture of aluminum and iron powder, you bring a magnet towards this powder. What happens? The magnet attracts only iron scrap materials, iron powder. It won't attract aluminum powder. So thereby you can separate aluminum powder from iron powder. And what is the technique used? Magnetic property is used here. Okay. So children, magnetic property is used to separate if iron powder is getting mixed with some other powder. It may be sand or it may be steel powder. Okay. So a magnetic property is used here for separation of solid components of a mixture. So, we have discussed 3 separation techniques. One is filtration. Under filtration, we discussed about sedimentation, decantation and sieving. Second one was evaporation. When do you do evaporation? When the components are completely dissolved. When the solute completely dissolves in the solvent, we use this technique, that is evaporation. And if the mixture is mainly solid and if iron powder is there in that component, you can use magnet. Okay? Magnetic property is used to separate the components. Children, there are some pictures given in your textbook, we will discuss that. Look at the picture, the first picture, I think copra is ground to give coconut oil. So, here the technique used is filtration. Look at the second picture, tea is being filtered, right. So, here also filtration technique. Look at the third one, that is threshing, removing husk, isn't it, from the paddy. And the fourth one is squeezing out lemon juice, okay, and after that you will do filtration. And look at the last picture, a lady is separating grains out of rice. So, what is the process called? Winnowing, okay. So, winnowing, threshing, filtration, these are some of the separation techniques which are given in your textbook. Now, children, we will move to the next picture which is given in your textbook. Look at the picture, a well is there, a small house is there and a toilet is also there, okay. So, all 3 are kept nearby. Is it correct, children? Okay. Now, usually in the wells you can see clear water. How will you get clear water in the wells? When the water is clear in the wells, what do you see beneath the well, underneath? What can you see? ഏറ്റവും താഴെ കിണറ്റിൻ്റെ ചോട്ടിൽ എന്തെങ്കിലും ക്ലിയർ ആയിരിക്കുമ്പോൾ കാണാറുണ്ടോ? What will you see? You will see sand. Here sand acts as a sieve, okay. Sand acts as a very good filtration particle, okay. Sand sieves water to give pure water. So, here in the well sand acts as a sieve to give clear water on the top portion of the well. Okay. Now, is there any chance for the water in the well to get contaminated if the septic tank is close to the well? Tell me, children, if you keep well and toilet nearby, that septic tank especially, you all know what is septic tank, right? What is septic tank? It's a tank which collects all the waste materials from our toilets, right? That is called septic tank. So, if the septic tank and the well is nearby, is it possible for the water from the well to seep to the toilet or from the septic tank to seep through the well? Rendu vellam kudi mix avanla sadhyadayundo? Tell me, children. Yes, because in between there is sand. Sand ulladondu endu nadakkum ee water angottum ingottum mix avanla sadhyadakal koodudalana, because sand acts as a very good sieve. So, the water from the septic tank might seep through the sand and it might reach the well and it may get contaminated. Kudikan pattadiyavum. So, always while constructing house, we should see to that the septic tank is never close to the well. Okay, children? So, make it a point. Why should not be septic tanks near the well? Because the sand beneath the ground, it acts as a very good sieve and it might help in seeping the water from the septic tank to the well. So, it is not advisable to construct septic tanks near the wells. Okay, children? Hope you have understood this chapter good, right? So, both the techniques are very important. Okay? We studied about different techniques. According to situations, we should know where to apply these techniques. Children, the concept map which is given in your textbook will be sent through WhatsApp. Okay? Now, we will move to let us assess. Observe the materials given below. A is wax powder, C is salt, B is iron and D is sand. How can you separate the components if A and B get mixed? What is A? Wax powder. What is B? Iron. Tell me, children, wax powder and iron is getting mixed. How will you separate these two components? First thing, both are solid and it is a mixture, and moreover in this mixture there is iron powder. If iron powder is there, what method should be used? We should use this magnetic property. So, if you use a magnet, what happens? All the iron powder is separated from the wax powder. So, it is easy to use wax powder. Okay? You can write it in the textbook itself. Using magnetic property, we can separate wax powder from iron powder. How can you separate components A and C get mixed? What is A? Wax powder. What is C? Salt. Very easy, right? How will you separate salt from wax powder? You dissolve the mixture in water. What happens? Salt will dissolve. Once the salt is dissolved, what happens? The wax powder will settle down in the glass, isn't it? Whatever container you have taken. You filter it, what happens? Wax powder is separated. Now, how will you get salt from the water? You do evaporation, you will get salt also, right? I think we will write all these answers in the file itself. Now, the third question, how can you separate the components if A and D get mixed? What is A? Wax powder. What is D? Sand. So, you can do two techniques. Wax melts when it is heated. So, if the mixture is heated, wax melts and it can be strained out, then you will get sand separately. You can do another method also. Take a bucket of warm water and add the mixture to it. What happens? The sand particles which are heavy will settle down the base of the bucket, whereas the wax floats in the warm water. You can just strain away or take away the wax particles and you will get sand separately when you filter the water. So, this is a technique used to separate wax powder from sand. Okay? Next, second question. Using which equipment will you get water with maximum purity while filtering muddy water? Why? So, which equipment you will use to get pure water? Is it a cloth, filter paper or tea strainer? You know the answer. Answer is filter paper. How does pure water different from sugar solution based on the constituents present in them? The answer for this will be sent through WhatsApp. What is the difference between pure water and sugar solution based on their components? So, you can use it. This question is difficult, answer is there within you. Pure water, what is the significance of pure water? You should answer using these technical terms. Pure water contains only one molecule. So, it is a pure substance, whereas sugar solution contains two types of molecule, sugar molecule and water molecule. So, two types of molecules are present there. So, it is a mixture or solution. You can specify it, it is a homogeneous mixture or homogeneous solution. So, you should answer based on the components present in these two substances. Okay? So, I hope you understood this lesson clearly. Bye children, see you in the next class with a new chapter. Bye, take care.